All right, everybody, it is review time. All right, we're going to use this diagram to answer the questions. Assume that P is parallel to Q. Remember, it needs to be parallel, otherwise you can't do any of this. So first question says 1 and 3 are congruent. So that's 1 and 3. They're congruent because they are vertical angles. So vertical angles mean they're formed across two intersecting lines. So 1 and 3 are vertical. What about 3 and 7? 3 and 7, they're in the same space, but in a different location. That's corresponding. Corresponding angles. What about 4 and 5? 4 and 5, they're on opposite sides of this line, but they're inside the parallel lines. We call this alternate interior angles. Alternate interior angles. You can be lazy and write alt-int, just the first 3 letters of each word. Okay, 2 and 8. 2 and 8, 2's here, outside, 8 outside, but on opposite sides of this transversal line. So these are alternate exterior angles. Again, you can shorthand it, you can write alt-ext angles. Exterior. All right, E, 1 and 6 are congruent. So what about 1 and 6? 1 and 6 is just corresponding again. Everyone loves to forget corresponding. 3 and 6. 3 and 6 are congruent because they're, so this is another example of alternate interior. So 4 and 5 are alternate interior, so are 3 and 6. Alternate interior. I'm lazy, I'm just going to write alt-int. Alternate interior angles. All right, moving down. 5 and 8. 5 and 8, 5, 8. Oh, these are vertical again. See, 2 intersecting lines, and they are across each other from the intersecting lines. So again, vertical angles. All right. Now we got H, I, and J. So measure of angle 1 and 2 add to what? Well, they're next to each other. They add to 180, and we call those supplementary angles. So measure of angle 1 and 2 are 180 degrees because they are supplementary angles. We can also call them a linear pair because they are touching. 1 and 2 are right directly next to each other. I think the word was adjacent. 2 and 7. 2 and 7. Scrolling up. So here's 2, and here's 7. Well, we know that 2, we can slide 2 over to make the same as 5, and then 5 and 7 are also 180. So if 2 and 5 are the same, and 5 and 7 make 180, then 2 and 7 make 180. We call this same side exterior because they're on the outside, like I could pull it up, and they're on the same side of the transversal. So this is same side same side exterior. So they're 180, same side exterior. Same side exterior. I ran out of space. EXT, you know what that means. All right, 4 and 6. 4 and 6, here, this, and this. So they're on the same side, but they're on the inside. That looks like a smiley face. So same side interior angles. So 180 degrees because they are same side interior angles. So please make sure to be able to identify all of these. And we don't really need to worry too much about 90 for this one. It's mostly 180 in this case. All right, let me just erase this. All right. Next page. Okay, use what we know about triangles and angle relationships to determine the following values represented in triangle A, B, C. Let me zoom out. I'm going to need some more space here. So I got all this. Whoa, I got to find X, Y, I got to find AB, I got to find AC, and all 3 angles inside. So, well, I see a tick mark here and another mark here. That means this is an isosceles triangle. So we can write the word isosceles. Just remember this is an isosceles. I hope I spelled that right. Isosceles triangle. Which means these two sides are congruent, the left one and the right one. Well, if these two are congruent, then doesn't this equal to that? Which it does. So let's set that equal to each other and solve for the x. 5x minus 4 equals 9x minus 20. I don't need two x values, so let's subtract the 5 from both sides. So minus 5x minus 5x. And what happens? The 5 and 5 will cancel. The negative 4 will come down. Equals 9 minus 5, that's 4x minus 20. Right? And again, I'm solving for x. So great, what do I have to get rid of? I got to get rid of the 4, but I have to get rid of the 20 first. So I got to add 20 to both sides. Boom. Boom. Negative 4 plus 20, that is 16. If you're not good with this negative addition and stuff, you have we can provide you a calculator for x. And then I divide 4 on both sides. And what do I get? I get x equals 4. Because 16 divided by 4 is 4. Great. X is 4. So now that I found x, it makes it a lot easier to find everything else. Okay, can I find y though? Well, I have only this, and I don't really know anything else. So I really can't find y yet. I got to find everything else, and then maybe I can find y at the end. Okay, what's next on the list? Measure of angle AB. Okay, AB is AB. That's this one. So AB is 5x minus 4. Well, I have x. It's 4. So let's just put, instead of the x, let's put 4. 5 times 4 minus 4. 5 times 4 is 20, and 20 minus 4 is 16. Oh, great. So AB is 16 units. What about this one? Let's do the same thing here. So 9x minus 20. 9 times 4 minus 20. 9 times 4 is, I think it's 36. Yeah, 36 minus 20 is 16. Oh, I noticed they're the same. Oh, and guess what? I wasted my time. Because if this is 16, then shouldn't this be 16? Absolutely. So I didn't even have to do all this. This was just, oh, it was extra, but whatever. Great. Let's go to the angles then. That. So remember, if you have an isosceles triangle, not only are these two sides congruent, these two angles are also congruent as well. That angle is congruent to that angle. So let's just plug in x here. So 10 times x, and x was 4, plus 15. 10 times 4 is 40. 40 plus 15 is 55 degrees. Now I know since this is 55, this is also 55. You could just write 55 here, but I'm going to write out the math anyway, just because it's good to practice. So that's going to be 20 times 4 minus 25. Right, 20 times 4 is 80. 80 minus 25 is 55. Great. So what's 55? Angle B is 55 degrees. Angle C is 55 degrees. So last thing, I got to find A and whatever Y is. Well, since this is a triangle, all three of these angles need to add to 180. So I have 55 here and 55 here. That means I got to figure out what this last thing is. Remember, they both add to 180? So 55 degrees plus 55 degrees plus some number has to equal 180. So the way I do it is I'd subtract. I'd do 180 minus 55 degrees minus 55 degrees gets you 70. Great. So A is 70 degrees. Oh. Unfortunately, I have not finished my problem yet. I still need to solve for y, and I've covered that up. So I need to solve for y, and I'm going to use this 70 to help me find y. I couldn't do any of this until I did that first. So, well, that's, what do you call it? 8y minus 10 equals 70. Great. I know it's 70, so I can set it equal to 70. Time to solve. Add 10 to both sides. You may totally skip this step if you want. All this extra stuff that I wrote in red you really don't need it. It'll actually make your work a lot complicated. And when you get to different level classes, it will actually mess you up more than help you. So you want to learn to skip steps. Divide 8 on both sides. The 8 and 8 will cancel. Y will equal 10. Beautiful. So in order to solve this problem, there were two concepts that I really needed to understand. I knew that this side and this side are equal. I also knew that these two angles were equal. And finally, I knew that all three of them had to add to 180. Not the sides. The three angles inside must have added to 180. So those are the, I guess, the 2 or 3 concepts you really need to understand to be able to do this problem. All right? Cool, cool. Next. Great, proofs. Lovely. So before jumping right into a proof, remember, mark your diagram first. So let's look at our givens. PR bisects QPS and QRS. So remember, bisects means it cuts it into 2 equal halves. So QPS is this large total left side of this like sideways kite thing. QPS has been cut in half. So QPS, these 2 pieces are congruent. What else is congruent? Oh, I know that this side in the middle is congruent to itself. What else do I know is congruent? The third side, these parts right here. QRS has been cut in 2 by the bisector. Right? So those are my givens, and that's the information I could really figure out. Now, however, the question is asking for PQ and PS. They want me to prove that these 2 are congruent. To be honest, with the information I have, there's really no way to tell they're congruent. So what I'm going to do is prove that the whole triangle is congruent. If the whole thing is congruent, then these 2 pieces inside should be congruent. So we're going to actually prove the whole triangle is congruent first. Then I can prove that the side is congruent. So I don't have anything written here, so I got to write that. Statement and reasons. So I'm going to extend this far. And I'm not going to write my reasons because this is pretty long. I'm going to put that in first. So first thing I wrote, PR bisects QPS and QRS. Time to copy that down. So the segment PR bisects angle QPS and angle QRS. So now that I know how much space I had, now I can draw that line. And then let's write reasons. I may need to extend it more based on how much I need. So this is your given statement. Doesn't hurt to mark your givens first. All right, next. All right, so what did I just do? This. The ones I did in blue are congruent. So these angles, this is angle QPR. So I write angle QPR is congruent to, what's the other angle? SPR. Angle SPR. Yes, I did that right. And the reason why they're congruent is because of the bisector. Whenever the reason is just, oh, it's because it's this, we just call it definition. It's the definition of bisector. Notice I shorthanded it. You may absolutely shorthanded things. You may absolutely shorthand things. You don't have to write the whole word. That's a waste of time. All right, right afterward, we determined that this side inside, it's the same side, so we know they're congruent. So PR is congruent to itself. PR is congruent to oops, not R. PR. And this is the one that everyone remembers. This is called the reflexive property. Reflexive property means, and I'm going to be lazy and just write PROP. You don't have to write the whole thing. Reflexive property means that everything is congruent to itself. And the last one, the one I did in purple, this is also because of the bisector. And remember, we have to use 3 letters. That's QRP. Angle QRP. QRP is congruent to angle SRP. And that's also because of the bisector. Definition of bisector. You don't absolutely have to write this twice. If you want to draw an arrow from here to here, I mean, I'm not going to be mad. Great. Also, these three don't have to be in order. You could have done these all out of order, but the given must be first. Right? So, great. What do I have an example of? I got angle, side, angle. So these two triangles are congruent because of the ASA, the angle, side, angle postulate. So that's what I'm going to be writing. The triangles are now congruent. So triangle QPR, QPR is congruent to triangle SPR. I don't really care about the order of the letters. You can write them whichever way you want because it's a triangle. No one cares. They're congruent because of the angle, side, angle postulate. So ASA postulate. You could just write ASA if you want. Now, this proof did not ask me to prove the triangles are congruent. They wanted me to prove these two sides. Since I proved the whole thing is congruent, I know these sides are congruent. So like, if you can't prove it, you might as well prove everything around it. Then it has to be congruent. So PQ is congruent to PS. PQ congruent to PS. And that is because we called this was a weird acronym. CPCTC. Remember, that stands for, let me write it here, CPCTC. That means corresponding, this is hard to write, I regret this, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Why don't I draw a line so it's actually easier to see? Yeah, this was a bad idea. Congruent parts of congruent triangles are congruent. CPCTC. Probably should have done this the other way. Anyway, moving along. Second one. All right, let's mark our givens and then think about what we're supposed to do. So AB is parallel to CD. Nice. AB and CD are parallel. What else is parallel? BC and AD. Cool. Let's put 2 this time. We need to prove that angle A is congruent to angle C. This one here and that one there. Again, with this one, it's really hard or almost impossible to prove that these two are in C. Actually, no, it's possible. It's just really hard. So we got to prove the whole triangle's congruent. Then we can prove that those are congruent. So we're going to be using CPCTC again. So what do I know is congruent based on the picture? Well, if you look at these two triangles, BD is congruent to itself. That's a reflexive property. There's also this alternate interior angle nonsense. Well, I can't say B. CBD is congruent to ADB. These are congruent because they are alternate interior angles. On the first page, we said those are congruent. What else also alternate? These are also alternate interior angles. That. So these are now congruent by what? Angle, side, angle. Oh, it's ASA again. Remember, it's ASA and not AAS because the side is between both of the angles. So we're going to do this in order. Oop. So statement and reasons. Statements. I'm going to write the statements first and I'll write the reasons later. That was given. AB is parallel to CD, comma, BC is parallel to AD. Lovely. And now time for our right reasons. And our reason for this is it is given. Please write the given. It's the easiest first step to do. All right. So let's go in order of the ASA. So the first angle that you see in order is that's the purple one. So let's do purple. So ABD, ABD in that order. Angle ABD is congruent to angle CDB. Be really careful with these letters. It's extremely easy to mess yourself up. And this is reason is called alternate interior angles. I'm going to be lazy and shorthand everything. Alternate interior angles are congruent. Awesome. So that's my first angle. Let's do the side now. The side is reflexive property. BD is congruent to itself. BD is congruent to itself. That is called the reflexive property. REF, reflexive property. And I'm going to cut short there. A little more. Third one, I did that in green. CBD, angle CDB is congruent to angle ADB. These are all very similar sounding letters. And they're congruent because of alternate interior angles. So, shorthanded again, alternate interior angles are congruent. So that's my angle, my side, my angle. This is now congruent because of ASA. I got no space. Right, so these triangles are congruent because of angle, side, angle. Triangle ABD is congruent to triangle CDB. All right, these are congruent by the angle, side, angle postulate. These are both coincidentally the same. You should expect different ones. We got side, 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 angle, angle, and angle, angle, side. Also hypotenuse leg, no ASS. And now that they're congruent, now I can prove that all the parts are congruent. Right? There was no way to get A and C directly through all this info. So I had to find the whole triangle, and then now I can prove the little inside parts are congruent. So now A and C are congruent because of C, P, C, T, C. Angle A is congruent to angle C. We call this C, P, C, T, C. The corresponding parts of the congruent triangles are congruent. Basically means that the whole triangle is congruent, all the inside parts are congruent. If you don't remember C, P, C, T, C, don't obsess over, I don't remember the order of the letters. You could even write what this means out in a sentence, and I would accept that. All right, proofs are done, thank God. Next. All right, oh, this is mid-segment. People liked this one. So BC is the mid-segment of ADE. Fill in the blanks for all the statements below. So if BC is the mid-segment, that means two things. Well, a whole bunch of things, actually. That means AB and BD are congruent because mid-segment is made from the midpoint of the line. These two are also congruent. Do that in different colors because people were complaining it's the same color. So that's true. What it also means is that BC is half the length of DE. Also, BC is parallel to DE. So we're going to use all that information to finish this up. So if AD is 10, then what's BD? Well, if AD is 10, BD should be 5 centimeters. CE is congruent to what? CE is this. Well, it's got two. CE is congruent to AC. CE is congruent to side AC. Angle ABC. What is angle ABC? ABC is this thing. Now remember, we know that these two lines are parallel, so since these lines are parallel, we can actually use all of the weird angles. We can use alternate interior, corresponding, same side interior if we felt like it. That means this is corresponding to this. Great. We love parallel lines. They grant access to a whole bunch of theorems. Or stuff. Anyway. So that's congruent to angle D. And yeah, you can just use D here. Because D, there's only one angle. There's not multiple, so it's just that. Angle D. What about ACB? ACB, I'm running out of colors. ACB is congruent to, oh, this one again. Angle E. 2. Yeah, they're congruent. They're corresponding angles. So they are congruent. BC and DE are blank line segments. So remember, I marked this symbol. We know they are parallel. If you have a mid-segment of a triangle, it is always parallel to the third side, to this third side. So they are parallel line segments. All right, if BC was 7 feet, if BC was 7, then DE would have been, okay, it's remember BC is half the length of DE, so that's 7, double the 7 is 14. So that should be 14. Easy. Now, last question, ABC and ADE are blank triangles. So ABC is the little triangle on the top, and ADE is the entire triangle. Well, they're not congruent because they're not the same. We said these triangles were similar. Don't worry too much about similarity, though. They're similar triangles. Just know they're not congruent. We call those similar. Did I spell that right? Similar. All right. So we're good here. Last page. This is a terrible picture. Terrible meaning it's difficult. Figure ABCD is a quadrilateral. Points M, N, P, and Q are the midpoints of the sides of the quadrilateral. Well, if they're the midpoints, that means we have some mid-segments. NP is the mid-segment of this big top triangle right there. So NP is the mid-segment of ABC, which means it's parallel to AC and half the length of AC. Same thing. So we've got a whole bunch of mid-segments. So you got 4 mid-segments, so they all follow that same rule. They're half the distance of the third side of the triangle and also parallel to that. So if AC is 20 inches long, then how long should NP and MQ be? These letters are confusing. AC, if this long thing is 20, then NP has to be 10, because that is a mid-segment of this triangle. And MQ is also 10, because it's a mid-segment of this triangle. So this is 10, 20, 10. So they would both be 10 inches. So we're going to write NP and MQ would each be 10 inches long. We can't just do that. We got to answer why. How do you know? So this is because they're both mid-segments, so they're both half as long as AC. So this is because they are both mid-segments. I can be say they are both triangle mid-segments. We can do that. Triangle mid-segments. Which means they are half as long as AC. They are half as long as segment AC. Boom. NP and MQ would both be 10 inches long. This is because they are both triangle mid-segment. If they're mid-segments, then there should be half as long as this third side of the big two triangles that are making this up. And by triangles, I mean this one here, excuse my terrible lines, and that one there. Well, these are pretty bad. So this triangle and that triangle, like the big thing. The next question is pretty much the same thing. It's just the other side. So if MQ and PQ, so it's MN. If MN and PQ were 8 meters long, then how long should BD be? Well, these both are mid-segments. BD must be 16 meters long, and it's basically for the same reason. So BD should be, that does not look like an S, BD should be 16 meters long. And we know this because MN and PQ are both triangle mid-segments. This is because, what are the letters? MN, this is a lot of writing, and PQ are both triangle mid-segments. So if they're both triangle mid-segments, this means they are, that BD is twice as long as both of them. So this means, yeah, I think this is a run-on sentence. Oops. This means BD is twice as long. So it should be twice as long as 8. Right, you got 2 more. Are NP and MQ parallel? Oh, they're mid-segments. So let's think about NP. Well, NP is a mid-segment, so NP is parallel to AC. MQ is a mid-segment, so MQ is parallel to AC. Hey, look, they're both parallel to AC, which means they are both parallel to each other. So that's going to be a long explanation. NP is a mid-segment, so it's parallel to AC. MQ is a mid-segment, so it is also parallel to AC. Since they are both parallel to AC, they must be parallel to each other. Let's try not to make it that long. So are they parallel? Absolutely. Yes, they are parallel. They are parallel. So they are both mid-segments. And they're triangle mid-segments. They're not, there's no such thing as a mid-segment of another line, I don't think. They're both triangle mid-segments, so they are both parallel. Are both parallel to AC, which is the long side in the middle. Both parallel to AC. They're triangle mid-segments, so they are both parallel to AC. Since they are both parallel to AC, they are parallel to each other. Well, let's use a nice word. Therefore, they must be parallel to each other. Be parallel to each other. And guess what? Question D, it's exactly the same. MN and PQ, which are these sides, guess what? MN is parallel to BD. PQ is also parallel to BT, therefore they must be parallel to each other. I'm going to be very lazy, and I'm just going to copy paste this. So you get to watch wonderful technology at work. Copy and paste. Oh, there it is. I'm going to change the colors, and they're not parallel to AC. They are parallel to the other thing. They're parallel to, what's the other one? BD. Oops. Yes. The joys of being lazy and using technology. Awesome. Therefore, they must be parallel to each other. All right, so that's cool, and that's it.